So now let's move towards something a bit more interesting and closer to the topic that we really want to tackle, right? So for that, we need to understand a bit of set builder notation. So all I require right now is that you just know that when I write a bunch of these symbols, you know how I want you to read them. So we look at the first bracket and we say set of elements of form, or the set of elements of form. I look at whatever is written here and I just read it as it is given. That's a condition or a formula. I read this vertical line as such that. And I read this portion as it is given. It's another condition. So let's work with some examples. For example, let's read what this says. This says the set of elements of form X such that X is an element of the set of natural numbers. What this means is I have such a set where I'm going to pick elements of natural numbers. Since I don't have any further restrictions, I'm free to pick every single natural number. There's no restriction. So in a sense, this set is the same as the set of natural numbers. I'm free to pick any one of them. So I'll pick all of them. I can do that. And so these two sets are the same. But what if I said the set, let me erase the previous markings. Yeah. So what if I said, what if we look at this set and I said the set of elements of form X such that X is a natural number where X is divisible by 2. Well, for starters, it's a bit different because now I have a restriction. Now I'm not free to pick any natural number. I need to pick those natural numbers that are divisible by 2. But who are they if not the set of even numbers? If I pick every number that is divisible by 2, I will have all of the even numbers. In similar fashion, if I picked the set of elements of form X such that X is a natural number, and if I were to subtract 1 from it, what results is divisible by 2, then those are the odd numbers, right? How so? Like consider the number 3. I subtract 1 from it to get 2, and that's divisible by 2, right? So yeah, so this is a set of odd numbers, as you can understand. And then over here, this is read as the set of elements of form X such that X is an element of the set of integers. And furthermore, the negative of X is a natural number. But what does that mean? So if I were to pick elements from the set of integers such that if I multiply a -1 with those elements, I would get a natural number. It means I'm picking negative numbers. I pick a negative number, I multiply -1 with it, it turns into a positive number from the set of integers. So this is just the set of negative integers, because these are the only numbers satisfying the conditions that I've written here. Okay, now what if I told you to pick an integer such that the integer itself is not in the set of natural numbers, and neither is the negative, the version of the integer with a -1 multiplied with it. So the integer itself is not in the set of natural numbers, and neither is the negative of that integer. So this precise case can only be satisfied if I pick the number 0, because the number 0, well, even if I multiply a -1 with it, it won't be in the set of natural numbers. So there's only one element in this set. And finally, what if I told you to pick the set of elements of form, or the set of elements of, I guess, living humans such that they don't breathe? If I told you to pick living humans who don't breathe, well, I don't know of any, so I'm going to claim that there are no such humans. So the set is empty, and the empty set is denoted with a circle with a slashed line passing through it.